Welcome back. Welcome back. I am James Hanson, the Vice President and Publisher of Nextgov, Federal Technology Media Division of Government Executive Media Group. It's my pleasure to welcome to the stage Alex Measure, the Senior Economist at the Bureau of Labor Statistics for the Department of Labor, for an interesting use case and conversation. Alex will tell you a little bit about how he went from being a senior economist to an IT expert. And basically, for everybody out there that doesn't have an IT background, that this is possible to accelerate AI to improve and advance your mission. So I'm actually going to turn it over to Alex to talk a little bit about his role and the mission of Bureau of Labor Statistics.
Sure. So I'm an economist at the Bureau of Labor Statistics, and I work specifically in the Occupational Safety and Health Statistics program. But most of my work these days is in machine learning. I developed the machine learning system that now automatically classifies a large portion of the work-related injury and illness data that we collect, and I advise a wide variety of similar machine learning projects throughout the Bureau. The mission of the Bureau of Labor Statistics is to provide accurate and timely information about the U.S. labor market, working conditions, and price levels. We're probably best known for the unemployment rate and the inflation numbers, but we produce a lot of other important statistics that help keep the U.S. economy running. The way we produce this information one of the ways we produce this information is by collecting large amounts of data. And a lot of this data is messy. It comes to us in the form, for example, for the Survey of Occupational Injuries and Illnesses, it comes to us in the form of written narratives describing work-related injuries and illnesses. We collect about 300,000 of those each year. And in order to process that sort of information and produce information about the various risks in the workplace, we have to have something or someone go through all of those written descriptions and pull out the key pieces of information. Historically, we've done that manually, and as you can imagine, it's a lot of work reading through 300,000 of these things each year. We have dozens of people across the country who work on that. And what we found is that by using machine learning, we can automate a large portion of that process, and not only automate it, but assign these classifications more accurately on average than our trained human experts. And so that's allowed us to really transform the way that we collect and process this information for the Survey of Occupational Injuries and Illnesses, and it's now also allowing us to transform the way that we collect and analyze data for many other programs.
So we've talked about quite a bit this morning about how do you get started. So a lot of the use cases and conversations we hear today are focused around kind of the DoD intel community, who has certainly an important mission, but the Bureau of Labor Statistics, which I've learned is preparing for this, has a huge mission in that the investment community relies largely on the data that you have. So how did you get started in this? Anthony mentioned this morning kind of 5 kind of key areas that were reiterated in the last panel around certainly the skill set, so data engineers, data scientists, mathematicians, architects, the actual data, which you have a lot of, the infrastructure and kind of IT operations, having the use case, so what's the business case for actually implementing an AI or machine learning program or solution, and then certainly imagination and courage. Let's kind of walk through each of those a little bit, and certainly you have a little more focus in one or the other. But starting with the first, you were a senior economist, not an IT person. So looking at the skill set and resources from a workforce perspective, where did you start there in terms of ensuring that, you knew how to implement some of these things?
Well, before I was a senior economist, I was a junior economist, and one of my jobs was it was to review these cases, these classifications that were being assigned manually, and it's maybe not something you train for in economics, maybe not something that you love to do, but it was something that we have to do, and it's something that plays a very important role in our ability to produce accurate and timely information about the American economy. And so the starting point for me personally was a personal need to automate this, but also I think there was clearly a business need to automate this. It was clear that this was a very time-consuming and difficult challenge. It was something that affected many different parts of the organization, and so it was sort of an interesting task for me to think about as an economist. I think one of the surprising things about this whole AI machine learning thing is that you don't have to be a PhD from Stanford to start doing this stuff. I happen to have some statistics and econometrics background, and there's some excellent online courses. Coursera has some machine learning classes, and I took some of those. And I started using open source software to implement solutions to these challenges. And what we found was that it worked. It was not only a lot easier than we expected, but it actually worked a lot better than we expected. Going back 6 years or so when we were starting this, no one thought we would be able to match human performance on reading through these narratives and assigning classifications. And in fact, that's what we were able to do with these algorithms. And it was, it's not super hard to sort of take these things and apply them to your task, as long as you have a clear business need and you have a lot of training data that you can feed into these algorithms.
So talk a little bit about training data. What exactly is that? And, how does, moving down to that kind of next kind of requirement in terms of having the data, how do you ensure the integrity of the data? How do you start to input the data? But first, talk a little bit of the training data. What do you mean by that?
Yeah, well, so I should clarify that there are sort of different aspects of artificial intelligence. There's sort of the knowledge engineering artificial intelligence, which has been around for many decades. But where there's been a lot of sort of advance in the last 20 years is in a type of AI based on what's known as supervised machine learning. And in supervised machine learning, you have a bunch of training data, a bunch of examples of the inputs you receive and the outputs you want to get from those inputs. And you feed it into the computer algorithm, and it learns to perform that task. Now, this simple recipe has driven a huge amount of advance in artificial intelligence over the last decade. This is what allows us, allows other people to build, face recognition apps. It allows us to do speech recognition. Allows us to do self-driving cars. But the key part of this, the key ingredient, is that training data. And typically you need large amounts of it. We are very fortunate at the Bureau of Labor Statistics that we have that. We've been collecting this data for many years, and that's one of the reasons why we were able to apply this successfully. But I think a key thing to keep in mind is that many organizations, just by sort of manually performing some of these routine tasks, are generating the data. They're just not saving that data in a database so that they can later in the future use supervised machine learning to automate that. So I think, for us, really the data was the key ingredient. It's the hardest component of the whole sort of system to get, and I think it really is one of the starting points.
Is there a right amount of data that people should have when they start?
Well, there's been a lot of interesting developments in the machine learning field over the last 10 years, particularly efforts to what they call transfer learning. So, you train some system on image tasks, some different image tasks, and then you can take that pre-trained model and apply a lot of it to your own task, and you need a lot less data to do that. So if you happen to have a task for which someone else has already put together a lot of data, you can use those techniques to sort of transfer and get away with less data. But in general, the more training data you have, the better. When we started our work-related injury and illness classification system, we had, I think, 300,000 training examples. And you can get by with fewer, but the more you have, the smarter it gets.
So then, now moving into the infrastructure piece, which is managing that data, storing that data, tagging, orchestrating all of that data into a system. What type of infrastructure did you guys have? And to that point is, how did you work with the IT group in order to kind of implement this, right? So, we have the IT side, the IT operations managing that, and then certainly the mission subject matter experts. You have a lot of those on there. How did you work with them? Where was the intersection? Can you talk a little bit about that?
Yeah, well, I think close collaboration is one of the critical pieces of making these systems work. In terms of the computing infrastructure, you used to need expensive supercomputers to do this machine learning stuff. Now we all sort of carry those around in our front pocket. So our initial auto-coding systems were developed on a government-issued laptop, and even with that relatively accessible piece of hardware, you could train a system on a million data points and get something that worked really well. But once you build that system, you really need to integrate it with your IT systems to make it useful. And that's really where the collaboration happens. You have to, it really comes down to people working side by side with a shared objective. That's not always easy in an organizational structure where you have these different sort of silos. You have the IT silo and the program office silo. But I think the organizations that have been most successful at implementing machine learning are the organizations that have been able to really break down those barriers and sort of get a sort of shared goal in implementing these systems.
So obviously, we talked a little bit about your use case and the need for this. In breaking down those barriers and silos, how did you, understanding the need that you had, how did you push that use case kind of through your organization? Did you go to the top up, top down? How did you kind of create that path to where you're at today?
Well, that's a good question, and I have to say that was by far the hardest part of doing this. And I think maybe anyone who's worked in a large organization knows that at a certain point, some of the biggest tasks become communication tasks. I had, in our case, I had support from senior management, which was critical. But we also did something that I thought was, ended up being very important. And what we did is we benchmarked human quality on this task very early on. So we'd known that, we'd been using people to perform this classification for many years, and we knew it wasn't perfect, but, it was sort of the best we could get. And so what we did at the very start was measure how good is this? How good are people doing? And that gave us a very clear, benchmark against which we could compare any automated solution. Without that benchmark, you're sort of flying blind. You're just sort of, hoping that it's going to work if you implement it. But with that benchmark, we were able to show the machine learning system could assign these codes accurately, more accurately than our trained human coders. And that was a very powerful message in, I think, convincing people not only of the importance of pursuing this, but also the need to pursue this.
How often did you check that benchmark as you started to add in data, run the models, analyze it? Like, how often did you do that until you, and it's an ongoing process, I'm sure, as you continue to advance the capability, but is, best practice that worked for you guys?
That's a huge part of this project, actually, is monitoring the performance of these systems, because these machine learning systems, it's the computer that's learning from the data. You don't really know everything that it's learning, and you want to make sure that the stuff that it's learning to do is the right stuff to do. And so we have these benchmarks. Before we make it, before we implement any system, we run it against the benchmarks, and we're continuously expanding the benchmarks so that they are more recent and more relevant to the data that's coming in, and so that they're larger and more representative of the type of information that we get. So that's a critical part of implementing these systems and using them and maintaining them.
And how in between now are those benchmarks as you continue? What's the confidence level of the outputs of the machine learning program?
So it's changed. One of the things that our machine learning system does is when it reads a narrative describing a work-related injury, it says, I think there's a probability of 70% that this is, a fracture or a rash or something. We use those probabilities to control sort of what gets auto-coded and what gets manually coded. If the computer is really confident, it tends to be right more often, and we can use that to say, okay, let the computer do that one. Have a human look at this other one where it doesn't really know what it's doing. It gets better each year. Each year we have more training data. So we retrain the model on that training data. We re-benchmark it to make sure that it's still doing what we want. And so it's sort of an annual process for us right now.
If anybody in the audience has a question as we're going through, as you're thinking through your own AI, all right, we got one right here. Nice.
Please hold for the mic.
We have a microphone coming here.
So you retrain it every year, and you have a benchmark, but is the benchmark correct? Is it 100% right or 90% right? And each time you retrain the algorithm, what do you look for in terms of accuracy? How many people are miscategorized? How many instances are wrong versus, past history? How do you do metrics is what I'm asking, because one of the limitations I see is that with AI, can you get 99.9%? In most cases, no. It's going to be much, much worse. So if you're in machine vision, for example, you want 99.9% accuracy, well, you're out of luck. So, yeah. What do you do to make sure that you're, is it just a feeling you have, or the general trend of the data?
No. So, we use standard classification metrics, and we use two metrics in particular. We use accuracy, which is just the portion of classifications that it gets correct. And we also use something called the macro F1 score, which is, you can think of it as an accuracy for each specific classification that gets assigned. So, it's an accuracy at identifying fractures, and an accuracy at identifying cuts, and an accuracy at identifying bruises. And we use that, we average across those to get some measure, a quantitative measure of the performance. Now, yeah, you're right. Building these benchmarks is really hard. What we did, because there's always some sort of uncertainty about how these things really should be classified. And if you've spent much time looking at the data, you'll see there's lots of stuff where it could go in a few different ways. To build our benchmark, what we did is we had a team of experts sort of recode each of these injury narratives that we got. And then we had a fourth expert come in and resolve all the disagreements that came out of that recoding process. So it's not a perfect process for sure, but it's, I think, about as well as we could do with the resources we have available.
Oh, we have one right here.
Hi, good morning. Thank you. So, how did you reduce, this is probably a different question, the biases also in your system?
Well, so I mean, the first step is really measuring the biases, and we haven't seen a lot of evidence of biases yet in our measurements. We're constantly trying to improve our ability to measure these things, but we also do a couple other things. One thing we do is we still have people going into each of these cases and reviewing the codes that are being assigned. And we ask the staff to, if they notice any patterns, to report those to us. Certainly bias is something that we are very concerned about, and it's one of the reasons why we invest so much resources into monitoring the system and to verifying that the codes are being assigned correctly.
We have one in the back there.
So you had discussed briefly that you got into it. There was easy tools that you could do online. And then there was a bit of a jump from there to working with a team of experts. Can you talk a bit as to how you engaged with the larger community, how management helped you? Did you take training? How did you come to find these experts out there? Could you throw a few words at that?
Yeah, so I think one of the cool things about the machine learning community is that they make almost all of their stuff available online for free. So I happened to be getting started when Coursera was launching. It's one of these massively online courses. And it happens to have been founded by, among other people, a machine learning expert, Andrew Ng. And I took his machine learning class. I also took a natural language processing class from Dan Jarafsky and Chris Manning at Stanford. And those were free. So there are amazing free resources out there online that you can learn about these things. And then there are also amazing free open source tools. So for example, scikit-learn is a library for Python, contains implementations, very efficient implementations of many of the most popular, I guess you'd call them shallow machine learning algorithms. There's now TensorFlow and PyTorch, which are very powerful software libraries for building neural networks. So there's a lot of expertise just sort of out there waiting for people to Google it.
Any others? Oh, we have one right here.
Thank you. So in regards to the retraining process, I just have 3 questions. When you retrain this process, do you do anything to deal with the data that is incoming? For example, exponentially weighting it?
So that's a great question, and I wish we had a good answer for it right now. If you have a good answer, I'd be interested in hearing it. One of the things we observe with the work-related injury data is that it does not tend to change a lot over time.
Okay.
So we don't do any sort of exponential weighting right now. Right now, we're just sort of weighting all of it equally. But one big question for us is, what do we do about the stuff that the system coded itself? Do we retrain it on these cases that it's coding on its own, and then becomes sort of a self-training system, which may not be what we want. So far, that's what we've been doing. But I think we're going to have to rethink that or think more carefully about that going forward.
Great. So when you retrain and redeploy the model each time, are you getting new classes in this multi-class, multi-label problem, or how do you identify new classes?
So we have a set classification system that we develop, and it tends to stay static over a period of 10 years or so. And so the set of possible classifications doesn't change, in a sort of official sense. But there are things that come up that we haven't seen before. And so one of the ways we deal with that is we try to prevent the autocoder prevent the system from classifying those things and leave those to people, because people are much better at dealing with these these new injuries that happen to occur.
Great. And last point, so when you redeploy the new model, are you just retraining it, or are you also making improvements or upgrades to the model? And if it doesn't meet the benchmark, do you revert to previous models?
Good question. So we are doing both. We are retraining on the data that we have, and then we're adding new features if we discover new things that might be relevant.
Any other? Well, got one more back in the back there.
Hi, you said you're still working with your human experts, certainly to come up with your initial categorizations and benchmarks. And then I think you just said you have people review each of these things anyway to review what the system has done. Are people looking ahead to saying if this thing is fully implemented, I'm out of a job? Is that a factor that comes into your workforce relations?
So yeah, that's a good question. One of the issues that we face is we have more work to do than resources to do it. So I think there was a worry that people would be thinking that early on. That doesn't seem to be the reaction that we've gotten from the people that do this. The people that do this are out in our field offices, and they're not just coding this stuff, they're also calling up respondents and trying to get the data. They're going through and checking for errors. They're going through and filling in pieces of information that we need to get filled in. So they have a lot of tasks to do, and even if we were able one day to fully automate this, they would still have a lot of work.
I think we're getting short on time, so I did have one question that we talked about a little bit beforehand, is that this difference between shallow machine learning and deep neural networks, which is where you are starting to kind of move into. Can you talk a little bit about what's the difference of those?
Yeah, I mean, it's a sort of interesting thing because in some ways it's an extension of the shallow learning. If you look at, if you're familiar with logistic regression, it's sort of taking in some inputs, producing an output. If you look at a neural network, it's sort of a bunch of logistic regressions sort of connected to each other in a network. So there is, there are a lot of similarities. One of the things that you get from building these neural networks is you tend to get these more powerful models. You tend to get better performance. You tend to be able to better capture hierarchical relationships that might exist in the data. You can also capture certain, sequential and other spatial relationships with these neural networks that are a little trickier to do with the shallow networks. But at least in my mind, it's sort of just an extension of the shallow machine learning.
Excellent, excellent. Well, thank you. I know we're out of time. Are you sticking around for it?
I'll be around.
Excellent. So if you have any further questions, please, Alex is available in terms of best practices. I think that going from looking at an NGA and NSA mission to a BLS mission to more citizen-centric missions that a lot of you have, AI is not out of the realm of possibility. It's not Star Wars. We're getting there. And I think that this is Alex is a great use case of you don't need to have a deep technical background to really understand the need in your agency and implement it. So thank you so much, Alex. Really appreciate it.
Thank you very much.